Okay, so we are continuing with the Pythagorean theorem today, and we're looking at word problems. Here is our first word problem. Calculate the length of the diagonal of a rectangle whose sides are 14 meters by 48 meters. So what we'll do is step one, which is draw your diagram. So I'm just going to draw out a rectangle, and we know it's 14 meters by 48. So 14 meters, this is 48 meters. And we're told that we need to find the length of the diagonal. So that means we're basically looking for the length of the diagonal that goes like this. From corner to corner, my image is a little bit off, but from corner to corner would make the diagonal. All right, that is what we need to solve for. So what we have here are two right triangles. So using either triangle, you'll be able to get the diagonal here. All right, so just remember this is the right angle there, there's a right angle there, and so therefore we're solving for this diagonal, which makes it the hypotenuse. So I'm just going to label it C here. That's what we're solving for, the hypotenuse. All right, so we know our formula, the Pythagorean theorem, which is that a squared plus b squared is equal to c squared. All right, so we get 14 squared plus 48 squared will give me c squared. So 14 squared plus 48 squared, I'm just going to put that into my calculator. That gives me 2500 is equal to c squared. So remember to do that last step here, we have to take the square root of both sides to get our answer of just c, not c squared. So the square root of 2500 is 50. So 50 is equal to c, and that is our diagonal. So lastly, you could just write your statement here, which is the length of the diagonal is 50 meters. Okay, so we have a ladder question next. So a ladder is 3.125 meters long, and it's resting against a wall. All right, so here's the wall, and then there's the ladder. And we know the ladder is 3.125 meters long. All right, and we also know it rests against the wall at a point 2.5 meters from the ground. All right, so that means from here to here, like this is 2.5 meters. What we're trying to solve for is how far up the wall is the ladder. All right, so we're looking for basically A. All right, so using our Pythagorean theorem, we can solve for A squared. We can solve for A. So A squared is equal to C squared minus B squared. And C squared, C is the 3.125. There's our right triangle. So this is our value for hypotenuse. So 3.125 squared minus our b squared, which is 2.5 squared. All right, so that gives me 3.515625. And then last step is to take the square root of both sides. And I get A is equal to 1.875 meters. All right, so in this next question, we are given a diagram of a triangle, and we are given the following measurements. So A to B is equal to 13 centimeters. So I'm just going to put that in here. That is 13 centimeters. B to C is 21 centimeters. So I'm just going to show that from B to C, it is 21 centimeters from B to C. but we also know that B to D is 5 centimeters. I'm just going to show that right here. 5 centimeters for B to D. All right, and we need to figure out AC. AC is here. All right, so what you need to be able to see here is that there's two triangles. The first triangle here, triangle ABD, that's one triangle, and our other triangle would be triangle ACD, right there. So if we look at our triangle ACD, we don't have enough information right now to solve for AC. So we have to do this in 2 steps. We'll have to figure out this length here, A to D, as well as D to C, and then we can solve for our length AC. All right, so the first thing we can do is figure out our length DC, because we have the total length from B to C is 21 centimeters. We know that the length from B to D is 5 centimeters, so we can just subtract to figure out DC. So DC is just going to be 21 minus 5, which gives me 16 centimeters for DC. So I'm just going to fill that in on our triangle. I'm just going to use a different color here to show that we just solved for that. So now we know 16 centimeters is DC. But we still don't have enough information to solve for A to C, right? We need at least 2 sides. So using this first triangle, ABD, we can solve for this length here. And because it will be the common length for both triangles, we can then use that to solve for AC. All right, so setting this up, I'm just going to call this step 1. We have to calculate AD, the length of A to D. Okay, so using what we have there, we have the hypotenuse and we have the base. We need to solve for our altitude. So A squared is equal to C squared minus B squared. A squared is equal to 13 squared minus 5 squared. All right, put that into your calculator and you'll get that A squared is equal to 144. Take the square root of both sides. And we get that A is equal to 12 centimeters. So therefore, AD is equal to 12 centimeters. All right, so going back to our diagram, I'm just going to fill that in now that we know our altitude here is 12 centimeters. All right, now we have 2 sides, and now we can solve A to C. All right, so that would be our step 2 now. Calculate AC. All right, and since this time, I'm just going to go back to our diagram. This time A to C is the hypotenuse. So we have our A and we have our B. So we are solving for C in our Pythagorean theorem. All right, so A squared plus B squared is equal to C squared. And so we have 12 squared plus 16 squared is equal to C squared. 12 squared plus 16 squared gives me 400 is equal to C squared. And then we'll just take the square root of both sides to give me 20 is equal to C. So therefore, AC is 20 centimeters.